So now we will get some hands-on exposure on Terraform. So here we will look into what is IAC and uh, how to install Terraform in Windows and Linux. Then we'll begin our first exercise, building infrastructure uh, in AWS, and then change infrastructure, destroy infrastructure, define input variables, and then query data with outputs, and then install or deploy application using Terraform file .tf. So now let's begin this hands-on Terraform with a same thing again. I just want to repeat it one more time. What is infrastructure as a code? IAC with, so we know what is infrastructure as code, but I just want to combine infrastructure as a code with the Terraform. So with the Terraform, with respect to Terraform, what is infrastructure as a code? So infrastructure as a code, IAC tools allow you to manage infrastructure with configuration files rather than through a graphical user interface. So IAC allows you to build, change, and manage your infrastructure in a safe, consistent, and repeatable way by defining resource configuration that you can version, reuse, and share. So Terraform lets you define resources and infrastructure in human readable declarative configuration files and manage your infrastructure lifecycle. So using Terraform has several advantages over manually managing your infrastructure. So the first advantage of using Terraform for IAC is Terraform can manage infrastructure on multiple cloud platforms that we have discussed. It's one of the use case of Terraform. So irrespective of the Terraform provider, so it can be applicable to most of the cloud platforms from GCP, Google Cloud Platform, Microsoft Azure, IBM, Amazon Web Services, and a lot, and so on and so forth. Then a second, the human readable configuration language helps you write infrastructure code quickly. So it's comparatively better. So when you see comparatively other existing system that we have, like bash and batch script and WSL, sorry, and then Windows, the PowerShell. So when you compare, and then Golang and other codes such as Ruby, Perl, and Python, when you compare with that, it's little better than them. So this is human readable, and you can write it quickly. And third, Terraform state allows you to track resource changes throughout your deployment. So we'll have terraform.tf file, .state file, .backup file. So the .state file, basically the Terraform state allows you to track resource changes, what's happening with your resource throughout your deployment. And the fourth one is you can commit your configuration to version control to safely collaborate on infrastructure. Here, it's particularly about the collaboration, and it's very much possible with the Terraform. So now let's look into uh, your let's look into the complete standard deployment workflow using Terraform. So as usual, So how do we manage any infrastructure using Terraform, that's my question. So that's what we are going to talk about, the workflow using Terraform. So Terraform plugins called providers, basically those are providers, let Terraform interact with the cloud platforms and other services via their application programming interfaces, API. So Hershey Corp and the Terraform community have written over 1,000 providers to manage resources on Amazon Web Services, Azure, Google Cloud Platform, Kubernetes, Helm, GitHub, Splunk, and Datadog. So just to name a few. So find providers for many of the platforms and services you already use in the Terraform registry. So if you don't find the provider you are looking for, you can write your own. So you can customize your own, you can create your own Terraform provider itself. So let's look into the standardized, just standardize your deployment workflow. So providers define individual units of infrastructure. For example, compute compute instances or private networks as resources. You can compose resources from different providers into reusable Terraform configurations called modules and manage them with a consistent language and workflow. So Terraform's configuration language, as we have discussed earlier in earlier slides, it is declarative, meaning that it describes the desired end state for your infrastructure, in contrast to procedural programming languages that require step by step instructions to perform tasks. Terraform providers automatically calculate dependencies between resources to create or destroy them in the correct order. So to deploy infrastructure with Terraform, so we the following is the flow that normally we follow, that you can see on the screen step by step. The first one is to scope. So what scope? Scope is to identify the infrastructure for your code. So for your project. So here practitioner who wants to do who wants to use IAC infrastructure as code and Terraform. So this is your first step. So the practitioner will write infrastructure as code. So their piece of code is ready here. So and the most important aspect, the flow in deployment flow, is scope. Identify the infrastructure for your project. What do you want to use, which cloud you want to use, and which service you want to deploy, all the things that is. And what's the size, what is the RAM, what is the memory. So all those things you have to identify the infrastructure for your project. That will be done by the practitioner, and he will write the piece of code dot .tf file. So then other. So once infrastructure as a code, so that's done. So then obviously you have to plan it, as we have discussed earlier. Terraform plan, you have to give that command, and after the plan is done, then you give Terraform apply, and then all the changes will be applied to the respective resources through the cloud, through the Terraform provider. The Terraform provider could be Amazon Web Services or Google Cloud, or IBM or Azure or anything. So then through that it goes and it will create either database or just normal instance or any kind of resource or any kind of service that you want to create. So that is the standardized deployment workflow. So now we are also talking about the overall steps or stages in the flow, in this workflow. So the first one is scope, as we have discussed earlier, and then the second one is other, So other he writes the configuration for your infrastructure. So this is the infrastructure configuration. This guy is the practitioner, this guy is our author, and this guy has written infrastructure configuration. So then it'll initialize. That's how a step-by-step procedure that we follow. So we are going to do this all practically in our exercise, but you just remember the each phase of this deployment workflow. So first one is scope, and second one is other, and then third one is initialize. Initialize is nothing but install the plugins Terraform, and install the plugins Terraform needs to manage the infrastructure. And then after that, plan. So plan is also very important without you using the plan command, don't directly go to apply. So plan is like it preview the changes Terraform will make to match your configuration, and finally once all done, you go for the apply command. So make the planned changes by applying the changes to the respective resource. So in addition to that, you track your mm, so after the apply, so in addition to that, you can track your infrastructure. Terraform keeps a track of your real infrastructure in a state file that's called dot state file. So which acts as a source of truth for your environment. Terraform uses the state file to determine the changes to make to your infrastructure so that it will match your configuration. And as usual, as we have discussed earlier, so the collaboration is one part that's very important in this. So to wrap this workflow, so deployment workflow, as usual, initially we have to look into the scope of the project. So basically we have to identify the infrastructure that is required for our project. Then based on that requirement, our author will write the configuration file for our infrastructure. Once configuration file is ready, then you use Terraform in it basically to initialize, to install the plugins Terraform needs to manage the infrastructure. Once the plugins of Terraform has been installed, then it's time to go for the plan. What plan does is it review the changes Terraform will make to match your configuration, and finally uh, so the Terraform will apply all the changes, apply the planned changes to your resource. Now let's jump into the action. So let's do the installation of Terraform. So we have different methods of installing Terraform based on the operating system you're gonna do. So whether it is Windows, Linux, or Mac, you have manual process as well as package manager. So if you use a manual processor, you have to follow a different one. If it is a package manager, it's a different one. Anyway, in this exercise we will be doing only installation only for the Windows. In further exercises we are going to do for the Linux also. So now let's go for the actual documentation of Terraform. So here if you find, this is the installation documentation for the Terraform. So we have different methods of installing. So one is manual installation, and then first we'll look into the manual installation, then we'll go for the, this is homebrew and chocolatey. This is chocolatey, a package manager, and then homebrew, this is for Mac, and chocolatey for Windows and Linux using package managers. See, this we will see it later. First we will look into the manual installation of Windows and Linux. So if you want a manual installation, the procedure is pretty simple. So what you have to do is, after downloading Terraform, unzip the package. Then Terraform runs as a single binary named Terraform. Any other file packages can be safely removed and Terraform will still function. So basically you have to get that Terraform binary file and place it into a proper directory that they mentioned. For example, first let us look into the Mac or Linux. For Mac and Linux, it's by and large same. So what you have to do is you have to print a colon separated list of locations in your path. So you have to get environment path. Echo is to print, dollar path is to print all the basically environment. Path is an environment variable, so that you will get it will print with this command. It will print a colon separated list of locations in your whichever is connected with your path environment variable. So once that is done, so meanwhile, as you have already downloaded the bin file of the Terraform, so then immediately you place that bin file into this location, / user local bin / after that your Terraform binary file should come. So that's it, your installation of binary file, sorry, installation of Terraform is done. Then you can verify using Terraform help. And then similarly for Windows, if you want to look it for Windows, let me just a minute, let me click on Windows here. So for Windows, as usual, this stack overflow article contains instruction for setting the path on Windows through the user interface. Okay, here it is not given, so I will only explain about the Windows. So basically, so Terraform works with automation softwares like Ansible after infra is set up and ready. So no programming. It has its own syntax which is similar to JSON. So Terraform is not using JSON. JSON is different, and then syntax of Terraform configuration file similar to JSON, but it's not JSON. So first, let's do the installation of Terraform in Windows. So for that, we have to, manual installation we will do, and after that we'll go for the we'll go with the automatic installation using Chocolatey on Windows. Okay, for manual installation here nothing is mentioned, so we're going to use our own technique. So now let me uh, type http, okay, Terraform downloads. So yes, we are in right place. Developer.hashicorp.com Terraform downloads. Okay, we are on the right place. So now here you can see this place consists of binary files for different OSs. First Mac OS, and then if you want for Mac OS, you just click on download and get it for your Mac OS, but we don't want that. For Linux, of course, you can directly use wget commands, or you can download it, whatever, whichever way you use, you can do it. That's not an for Ubuntu, it's wget, and for CentOS, you can directly using sudo yum install, and then Fedora, okay, DNF, and Amazon Linux sudo and then homebrew. It's again for Mac OS, and this is the one which we are going to use. And is there some other Solaris also? It's given, you can download this thing, but here in this case we want to download it for the Windows. So I will go for the AMD 64, so version 1.3.7. let me download this. Yeah, it's getting downloaded. So once it's downloaded, I will open it, and then we will extract that file. Yeah, so let me extract here only, extract it. Yes, this is what the binary file I'm talking about. I think it's visible, right? Yeah, I'll put it extra large icon. Yeah, of course it's visible at this moment, or large icon. Yeah, fine. So this one is the Terraform binary file. It's 59.2 MB. So this file, okay, you have to place it I'll open a file explorer, and then I'll get into no, sorry, get into c drive c drive. Where is that? Here it is. Then I'll directly open here a folder saying Terraform. Yeah, and this where is that? Here it is. Okay, it's there. Terraform. Yep, Terraform folder is there. So I'll just open this directory. I think it's visible, right? Okay, I'll make it bigger. If it's not visible, I'll make it bigger. I'll do anything for you. Anything for you. So whatever I do, it's only for you. It's not for my benefit. It's not to earn money. It's not to gain popularity. Nothing. Just for you service. Karmani eva baat karaste. Okay, so let me basically copy this location. Okay, it's ready. So now your binary file is placed into C drive in a folder Terraform. So now what I will do is I have to integrate this path into user's environment variable. For that, what I will do is I will type environment variable. So we got it. Directly click on this. Yes, I can make it bigger. You just follow it, please. I'll make this one bigger. Extra large icon. And here is my environment variable. Yeah, I'll click on environment variables, which is at the rightmost bottom. Then this window pops up. In that you have two boxes. The top box is about user variables for Surya, Charan, Teja, and then the bottom box is for the system variables. The system variables is not it's specific for the system. You don't need to touch it. Whereas user variables can be changed. So I'll click on path. That's where, and I'll edit it. Yes. So here I'm gonna add that path. So let me edit this. Sorry, let me click on new. It got open. So we have copied there. I'll paste it here, and then all done. Let me click OK. Yes, it's done. The binary file is set. Now it's all set. Now let's try to open the Terraform from our Windows PowerShell. Open it run it as an administrator. Yep, fine, no issue. Yeah, I think it's oh, I have to make it much bigger. I'll make it 736. Is it fine? I think 736 is fine. Yeah, this is fine. Let me clear the screen. Yeah. Now Terraform help. Congrats. That's it. So here is your Terraform installation of Terraform. Manual procedure through manual way is done. So you see Terraform. And how do you use it? Terraform, you mentioned global option and then sub command. Terraform is your main command, and then global options and then sub commands and then arguments. So it's all about the Terraform. The available commands for execution are listed below. So these are the commands. You have main commands and all other commands. So the primary workflow commands are given first, and those are the widely used commands, and then followed by less common or more advanced commands. So main commands, these are widely used. Init for initialization that we have discussed in our slides. Validate, plan, I told you, plan, init, plan, apply. These are very much important. So plan, show changes are required by the current configuration. Apply, create or update infrastructure, and destroy um, it destroys previously created infrastructure. So that's it. So this is a one way of installing. Let me clear the screen. This is the manual way of installing your Terraform into your machine. Of course, we have done it for the Windows. If you want to do it for Linux, you can do the same way, either using commands, or you can download it and place it in that binary, the user, uh, I think user bin. So there you can forward slash user forward slash bin, and then there you can place your Terraform file. Okay, so that we will look into that in our forthcoming slides and forthcoming exercises. But for now, so your installation is done in a manual way. So now we will try to do it using automatic process. Okay, so this for automatic, it's pretty simple. Let me click on chocolatey on Windows. I would urge you to do a manual process so that you will get more clarity on what is path variable, what is an environment variable, why we use environment variable. See, this is the classic demonstration of usage of environment variable, because I have been telling environment variable, environment variable, environment variable in Linux in module 2, but here we have classically demonstrated the purpose and the uses of the environment variable. Same thing we do it when we install Python. Okay, so for using Choco, it's very simple. Choco install Terraform. I'll just paste it here. Choco install Terraform and enter. Chocolatey version 1.1.0, installing the following packages. Terraform. By installing, you accept the licenses for the packages. So let me give S to all. Okay, removing the old Terraform plugins, and then it's gonna replace with the new one. So whatever we have done it in our previous thing, that of course we have used it 1.3.7 and AMD 64 only, but still we are doing it through Choco. So now it's going to replace the old one, and then it's going to place it in a different folder. Of course, it won't be the same folder. So it's a C program data chocolatey lib terraform tools. So in that it has set up. Okay, so now we will give the same command and we'll see terraform and then help. Yes, it's done, it got installed. So I hope you also successfully installed Terraform and validated the installation process using Terraform help command. With Terraform installed, you're ready to create your first infrastructure. So in this exercise, you will provision an EC2 instance on Amazon Web Services, that is AWS. EC2 instances are, I think most of the people you know that. If anybody it does not know, so it's for them. It's like EC2 instances are virtual machines running on AWS and a common component of many infrastructure projects. So now let's look into the prerequisites. So okay, so the prerequisites to execute this pro exercise. So we will write the prerequisites. So prereqs for building first infra first infrastructure in AWS. Okay, so the first one, as usual, the Terraform CLI 1.2.7. It is done and it was installed in our previous slide in our previous session. So then we need to have AWS CLI, it's command line interface. So, and then third one, AWS account. So then here we have to create IAM user. So there, and this IAM user should be configured with AWS CLI, so that from Terraform through AWS CLI we can operate AWS cloud. So it's like a remote for us. The Terraform is, it's like the best example I'll take is TV. You are watching the TV, you want to see a football match, the FIFA. So then you will change the channel through remote, and the change happens in the TV. So here this is you or you, and this is a remote control, and this one is our television. Okay, so that's the reason. But if remote to be work for this television should be configured with this remote. So that's what we are going to do. So I am user, after creating we have to configure this with the AWS CLI, and so we are gonna uh, do it. So uh, during configuration we have to look into a lot of other important concepts also. So that's what and I am user with here I'll write an access key. I am user with access keys. Then that's it. These are the fundamental requirements. Okay, so first we will Terraform was done, we have installed it. Then we will go for the AWS CLI. Then we'll go for the AWS account I am user with access keys. Okay, so as Terraform is done, now let's do installation of, I'll keep this aside here. So we will do the installation of AWS CLI. Let me clear the screen first. So to install AWS CLI, again I will use Choco. So let us go to the Chocolatey packages. Okay, Chocolatey packages. Packages Chocolatey. So accept, and then so there is some disclaimers and all that information. So basically here you can find the Chocolatey packages, and then this is our Chocolatey package manager. So Chocolatey software management for Windows specifically. So here you can search for what's that, AWS CLI. So you'll get Chocolatey CLI and a lot of information. I think it's a so you have to search for your packages, and then once you get the packages you can use it. So let's get back to our PowerShell. So Choco install AWS CLI. Yes, Chocolatey version 1.1.0 is coming to the action. And what's that? Installing the following packages. By installing, you accept the license agreement. Installed 01. So, warning AWS CLI already installed. So, AWS CLI is installed. So, I have a AWS CLI. So, you also follow with me and install the AWS CLI. Okay. So, that means I will check the second one also. So, 1 and 2 both are done. Okay. These two are done. So, let me mark it. So, now let's what what else is left? AWS account. I am user with accept with access keys. Okay. So, now let me get into the uh, Amazon Amazon Web Services. So I'm here, Amazon Web Services. I have my account, so I don't need to create an account. If you do not have, please kindly create an AWS account. It's not a big uh it's not a difficult task. Okay, you just create your own and log in through root user. Okay, so now for us the first thing to do is an IAM. Okay, IAM account. So I'll click on IAM service. So here I can create an user. So this is where I create a user. So I have clicked on, I have selected IAM user service. So at this moment I have, so I'm a root user using MFA, multi-factor authentication. So root user has no active keys, that's fine. So presently there are two users, it doesn't matter. So now I have to create one more user for this purpose. It acts like a to configure, basically to configure the TV and a remote. So here to configure the cloud and your AWS CLI that is installed in my local machine, to configure both, I need to create one user. So I have an existing user. So what I'll do is I'll I'll click on this. Okay, no, it's not required. I'll delete the existing user. I'll check it. It's I think 22 days back. 22 days back. Terra admin. Okay. Okay, it's done. Let me create a new user. So username I'll give Terraform. Okay, or else Terraform admin. Terraform admin. Okay, that's the username. And username we have given Terraform admin, or we can also give Terra admin. The simple one is this, the shortest one, Terra admin. Yep. So then select AWS access type. So I will go with the access key, programmatic access. I'll go with the programmatic access. Then I'll move for the permissions. Next permission, I'll attach existing policies. In that, anyway, I need all kind of access. So I'll go for administrator access. So then I will go to the next level after clicking administrator access. So I don't need to add any key, any add basically tags. I will move ahead. So Terra admin, so rest all, admin access and rest all, it's fine. So I'll create a user with the name Terra admin. So my user is ready with the name Terra admin and with access key ID, and this is the secret key, secret access key. So here is the file that whatever the access key and the secret key will be stored in this file. We can download that from here. So I have downloaded it. So please don't forget to download this. Okay, so once download is done, so your User is also ready. If you want to check, just get back to the IAM service and you can cross check it. Yeah. So users users yeah, TerraAdmin is ready. So meanwhile, let me, okay, here is the download file and here is that. I'll keep this window like this so we can use it later. So, or else I'll open this one and I'll keep it open. And so this is your access user credential file. Here you will find, okay, so all the information about access key ID. This is access key ID and this is secret access key. Both are important. Both are important. Okay. So just keep this file aside for a few minutes. We'll come back to that. So let's get back to the, so your AWS account is ready. IAM user with access key is also ready. So the third part is also ready. So what is left? So what's left is configuring the, so configuring the TV and remote. So configuring the AWS CLI with IAM with IAM user. That's a Terra admin. Okay. So this is left. So this we are gonna do now. Okay. For that again you have to open. Okay. Configuring now. For that we have to again open the Windows PowerShell. No, but this time we will use a git bash. Okay, so let's use a git bash because it's much easier. Of course we can do it from here also, that's not an issue, but still we'll use git bash. Okay, so let me make it bigger. Yeah, so to configure AWS, so type AWS configure. So first it's asking AWS access key ID. Where is that? Here it is. Access key ID is here. So I'll copy this and I will paste it. So then it is asking AWS secret access key. So let me get back to this file and copy the secret access key and paste it here. Then it's asking default region name. So which one is better? Let me check. So I'll get back to the instances. EC2. Yeah, it's taking some time. Today network is damn slow. I don't know why. Okay. Let's go to the EC2 global view. I think US East one is it's taking huge amount of time today. Yeah, I'll go with US Virginia. Virginia is US East 1. Ohio is US East 2. So I'll go with the US East 1. Okay, US East 1. So default region name. So I'll go with US East 1. Then default output as usual JSON. So that's it. Your the fourth activity is also done. That is your configuring the AWS CLI with IAM user. So I think all activities are done. So what's left? So your complete system to build an infrastructure is ready other than creating a configuring file, a Terraform configuration file. Configuration file. That's the only thing left. So what will we do is, so just to validate whether it is working or not, let's do Terraform here with help. Yes, we got the commands, main commands and all other commands and global options, everything we got it. So we'll check for the version also. Terraform and version option. Yes, it's Terraform version 1.3.7 on Windows AMD 64. So all set. Installation and installation and configuration is done, so you can write a Terraform script and provision provision infrastructure. So that is our next exercise of provisioning the infrastructure. Setup is done. So now it's time to write configuration to complete this build infrastructure in AWS exercise. The set of files used to describe infrastructure in Terraform is known as a Terraform configuration. So you'll write your first configuration here to define a single AWS EC2 instance. So each Terraform configuration must be in its own working directory. So for that, before you writing a configuration file, you have to create your own create a working directory, and then you place that you place that uh, instant configuration file in that working directory. So but before we do that, we will look into the configuration file once. As we have discussed earlier in our previous slides, uh, basically a configuration file consists of three components mainly. The first one is the Terraform block. So the Terraform block contains Terraform settings, including the required providers Terraform will use to provision your infrastructure. And for each provider, the source attribute defines an optional host name, a namespace, and the provider type. Terraform installs providers from the Terraform registry by default. So in this example configuration, the AWS provider's source is defined as HashiCorp AWS, which is shorthand for registry.terraform.io/HashiCorp /AWS. You can also set a version constraint for each provider defined in the required providers block. So the version attribute here, it is a required version, and then version, the main version, and then a required version. And here you can see the source. So mm, so the version attribute is optional, but we recommend using it to constrain the provider version so that Terraform does not install a version of the provider that does not work with your configuration. If you do not specify a provider version, Terraform will automatically download the most recent version during the initialization. That's the Terraform initialization. The second component of a configuration file is provider, the providers. So the providers block configures the specified. Here is the provider block. Provider is a block type, and then you have block label, then you have a block, and inside that you have the variable name identifier and then value of the identifier. So the provider block configures the specified provider, in this case AWS. A provider is a plugin that the Terraform used to create and manage your resources. So you can use multiple provider blocks in your Terraform configuration to manage resources from different providers. So you can even use different providers together. For example, you could pass the IP address of your AWS EC2 instance to a monitoring resource from Datadog. Datadog is another cloud kind of service. Okay. So the third component is resources. You can see here the third component is resources here. So the resource, so use resource blocks to define components of your infrastructure. A resource might be a physical or virtual component such as an EC2 instance, or it can be a logical resource such as a Heroku application. So resource blocks two have two strings before the block, the resource type and resource name. So here we have AWS instance and then app server, and then AMI, and then instance type. These are the two mm, so resource type and then a resource name. In this example, the resource type is AWS instance and the name is the app server, and the prefix of the type maps to the name of the provider. In this example configuration, Terraform manages the AWS instance resource with the AWS provider. Together, the resource type and resource name from a unique ID for the resource. So for example, the ID for your EC2 instance is aws.instance.app.server. So that's the example here we have taken. So finally, the resource block contains arguments which you use to configure the resource. So arguments can include things like machine sizes, machine disk image names, here disk image name AMI, and then machine uh, size, that's T2.micro, or VPC IDs, virtual private cloud IDs, or providers reference list, the required and optional arguments for each resource. So for your EC2 instance, the example configuration sets the AMI ID to an Ubuntu image, in this example to the Ubuntu image, and then and the instance type to T2.micro, so which qualifies for AWS free tier. So it all sets a tag to give the instance a name. So now all set up, yeah, here we have a tag. So here you can have the a tag, the instance name. Instance name here we have given is example app server instance. So enough of looking at um, theory. So now it's time to jump into the exercise and the practical exercise. So now let's create a file. So now let's use Sublime editor to write a configuration file. So we'll create a file with a name first tf instance, first 10 terraform instance.tf. For that we'll get into the folder, we'll just open the terraform, sorry, sublime text 3 by 3. So then we'll directly go to the folder. So we'll save that file directly so that we can get it, save as, and then here, so first instance dot tf, so automatically yes. So here it is, here is the file. So now we are going to write the required configuration file. So we will begin with the provider. So what is provider in this case? So we'll begin with the provider block. So the provider block configures specialized, basically the provider block configures the specified provider. In this case, we are going to use AWS. A provider is a plugin that perform uses that Terraform uses to create, manage your resources. So let me start writing a provider block first. Block type. So provider block type with AWS label, then we'll have a block opening, then inside that we'll write our first, that is a region, and then US East 1. Then after that you can include access key and secret key, but we have done the configuration of AWS CLI with the IAM user, so you don't need to do it here. So then we'll go for the another block, that is resources. Use resource blocks to define components of your infrastructure. A resource might be a physical or virtual component such as EC2 instance, so or it can be a logical resource such as Heroku application. So here for us it is an EC2 instance, so I'll write a resource and then AWS / instance is one label, then intro is another label. Then I will open the block. So first we'll begin with AMI, and then let me get the AMI of this thing from. I'll go to the EC2 instances, that is uh, Windows will create a launch new EC2 instance TF, and then let me get back here, browse more AMIs, and then from here you can copy the EC. So just a minute, AMI. Okay, just a minute, it's something. uh, okay, again let me copy it properly. Yeah, that's done. Copy and then paste it. So first argument is given, the next argument is instance type. So instance type, I'll go with the T2 micro, so that's more than enough for us. It's free tier also. So then I'll go with the availability zone. So availability zone for us is US East 1. Yeah, that's what we are gonna check. Then key name. So as we have created, what's the key name? Let me get back to that folder. Key name is TFKP. Key name is TFKP. So that's done. Then after that, VPC security group IDs. So for that we have to create a security group. Let me put, yeah, square brackets first, and then after the square brackets, so we can use this. So now let me get back to the EC2 instance security groups here, EC2 feature. This is EC2 feature. So I have a lot of security groups. Okay, let me close this. It's taking huge amount of time. Apologies for okay, it's hung. I'm sure. So from here you have to copy the security group ID and paste it in as a value to the VPC / security group / IDs. Okay, it's taking still more time. I hope it has to come a little earlier. So after that, after you attach a security group ID in that, so then you can go for the tags, and then so once tag is done, so then we will get into the actual work. Oh, okay. Anyway, I have the security group. I'll just minimize this part, and then I'll attach the security group SG, and it's 07808 15F 55104B8, sorry, B8A. So this is our security group. Now I'll attach tags. Basically, this is a block. This is a block inside a block. This is a nested block. For that, I will attach this things one more time, and then I'll begin with the name value. That is, so I'll give uh, first TF instance. This is what the name is. Then after that, the project is Terraform. Yes, all done. Let me save it. Yes, our first ever Terraform configuration file is ready. It's all set. So now it's time to execute. It's time to initialize directory. So let me open the git bash in the same directory where my key pair and everything is presented. Okay, so let me get back there and then open it. So this is the place where we have created, we have written our first configuration files. So that's the reason I'm opening my git bash here only. So yeah, so let me start with LSA. So here you can see clearly first in tf instance.tf. This is what I'm talking about. So ours is clearly ready. So now let's do the initialization of directory. So what is initialization of directory? So when you create a new configuration or check out an existing configuration from a version control, you need to initialize the directory with Terraform in it. If you know Git, we do git init. Similarly, we do Terraform init. Okay, Terraform init. So now initializing a configuration directory basically downloads and installs the providers defined in the configuration. So in this example, we have taken AWS. So let's execute this, initialize the directory and see what is going to happen. So initializing the backend, initializing the providers plugin, reusing. So Terraform has been successfully initialized. Kudos to you guys, whoever is following this session. I hope you also, your Terraform has also been successfully initialized along with me. And then you may now begin working with Terraform. You can do the Terraform plan, you can do the Terraform format, you can do Terraform validate, you can do Terraform apply, and everything, whatever you want, you can do it. So it's all set. But one more thing I would like to explain before we go in for the main commands of the Terraform. That is Terraform basically downloads the AWS provider and installs it in a hidden subdirectory of your current working directory named .terraform. Now we have to find out whether it's been done or not. When you, if you do it in git now, so when you do a git init, so the git folder will be created. Inside that, whatever the activities that happens, all will be happen inside that. Similarly for Terraform. Let's check. So ls, yeah, here it is, .terraform. So let me get into that. Yeah, ls, you got the providers. That's what it's saying. So Terraform basically downloads the AWS provider and installs it in a hidden subdirectory of your current working directory named .terraform. Inside that .terraform you will find the providers. Let me get into the providers, and here you see the terraform providers. Okay, let me ls, yeah, registry.terraform.io. So here you'll have all. It's a directory. So cd, let me get into that registry, ls. So hashicorp, let me get into that also. I'm going in depth. AWS, yeah, this is what is AWS here. In this case, in our case, it is AWS. The Terraform provider is AWS. So finally you got it. Let me get into that AWS also, and let me look into that AWS ls 4.50. So cd 4.50, ls, and windows AMD 64. That's what we got it. And then windows, and finally you got the Terraform provider AWS version 4.50.0.exe, that executive file. This is what I want you to see. So basically the provider, if you go for the another provider GCP, Google Cloud Platform, you would have that GCP Terraform provider GCP version and then .exe file. If it is IBM, if it is some other. So that's what I would like you to see, and then I will get back to the previous one. Okay, where am? Yes, we got it finally. Yeah, we are back into our current our present into our directory where our configuration file is there. So in addition to that, it also has created the dot lock file. So let me clear the screen and show you that. As it's mentioned, Terraform also creates a lock file named .terraform.lock.hcl, so which specifies the exact provider versions used, so that you can control when you want to update providers used for your project. So let me ls, uh, it's terraform dot lslrt. It's let me get into that version control and hands on terraform.tf instance. Okay, so when you do that, it automatically creates, when you do initialization, when you're doing that time itself, the log file dot terraform dot log dot scl will be created. So ls, and then yeah, so here is your file dot terraform dot log dot hcl. So let me do cat and then dot terraform dot log dot hcl. Oh, this is what it consists of. Okay, so this file is maintained automatically by Terraform init. So manual edits may be lost in future updates, so you should not edit at all. Okay, so let me clear the screen, and I've shown you that also. So now it's time to move up. So now we recommend, basically we'll do the format and validate the configuration file. So always HashiCorp Corp Terraform, they recommend using consistent formatting in all of our configuration files. So that's the reason Terraform format, Terraform fmt command, Terraform fmt command automatically updates configurations in the current directory for readability and consistency. So we have to format our configuration. So Terraform, so once we click on that Terraform as if you see that once you click on Terraform format, it has printed the file name. So Terraform has printed the names of the files it modified. So the first tf instance.tf is the file which we have modified it. So that's the reason it's been printed. So now we'll do it again, but this time there is no file has been printed because it was already formatted in previous time in the previously. So Terraform won't return any file names in this condition because it was formatted just a few minutes before. So it won't print it out anymore. So now let me clear the screen, and then we will we'll make sure your configuration is syntactically valid and internally consistent by using the Terraform validate. So the Terraform validate command, so validate your configuration. So in this example, our Terraform configured configuration is valid and we got success. Fantastic, we got success, brilliant. So now once we got the success validate, once we got the success message from the system, now it is time to create infrastructure, make it clear. So let me write terraform apply. So apply the configuration now with the terraform apply command. So terraform will print output similar to what you're gonna see on the screen at this moment. So it will take yeah, it's done. So it's asking for a value output to cell space, and then it's asking for a value basically. So do you want to want to add, or zero to change, or zero to destroy? So do you want to perform these actions? Terraform will perform the actions described above. Only yes will be accepted to approve. I will say yes. So I gave yes. So after, it will take few minutes. Basically there is some processing takes place before it applies any changes. Terraform prints out the execution plan, so which describes the actions Terraform will take in order to change your infrastructure master configuration. This is what the plan is: one to add, zero to change, zero to destroy. So only one instance is to be added. So that's what the plan, that was created by the Terraform. So that's the Terraform execution plan. So then after that the output format is similar to the different formats generated by tools such as Git. So the output has a plus, you can see here, volume ID, volume size, volume type, these are all being applied. So known after apply. So at least these things are being applied. At this moment they haven't applied, but once it is applied completely, okay, by the time by the time we discuss apply complete resources one added, it's all done, it's done. So but before we jump into the instance and check, so let's basically uh, get back to the screen output of the Terraform apply, and we'll look into the each activity that had happened throughout this execution of the command. So now if you see that the output format is similar to that diff format generated by tools such as Git. So the output has a plus symbol, you can see here the plus symbol next to the next to the the EBC block device, and for everything. So meaning that Terraform will create this resource. Terraform will give volume ID, Terraform will give volume size, Terraform will give volume type. So it shows the beneath that it shows the attribute that will be set. So when the value displayed as, here I'm talking about, when the value is displayed as known after apply, it means that the value will not be known until the resource is created. So for example, AWS sends Amazon a resource names ARNs to instances upon creation to. So Terraform cannot know the value of the ARN attribute until you apply the change, and the AWS provider returns the value from AWS API. So Terraform will now pause and wait for your approval, so that we'll get it in between. We gave that approval, and once it is done, so our plan will be executed. So let me show that. First, come down more, scroll on a bit more. So here, so this part I'm talking about, the here. uh, so Terraform has actually paused here, and it has waited for our approval before proceeding. So if anything in plan seems incorrect or dangerous, it is safe to abort here before Terraform modifies your infrastructure. So that's the reason one manual intervention is required. So there you have to type, in this case, the plan is acceptable. So I typed yes. You can see that I typed yes. So at the confirmation prompt to proceed executing the plan. So it took a few minutes. Then Terraform EC2 instance is available. So now what you have to do, you have now created an infrastructure using Terraform. Now it's time to visit the EC2 console and find your new EC2 instance. Finger crossed it will work. So I'm in the EC2. I'll go to the EC2 instance. I'm in the let me so instance 1 is running. What is that? I'm not sure. So let me click on this, because that's it. Congratulations, guys, whoever is following this and then doing along with me. So we have created our first instance. The name that we have given is first TF instance. If you have any doubt, let me show the file. So the tag is first underscore TF underscore instance. So that's what. And then here is your instance. Here is your instance. So security group, key, pair name, TFKP, launch time just 57 seconds before. So this is the public IP, and availability zone that we have selected, US East 1A, US East 1A. And so that's it. All checks passed. Instance ID. So let me click this. That's it. Successfully we have created our we have built our first EC2 instance in AWS using Terraform. So the first build infrastructure exercise is done. Congratulations, guys. Keep your morals high and follow me for the next exercise. So now, as we have created or built our first infrastructure EC2 instance in AWS, so now it's time to inspect. So when you applied your configuration, Terraform wrote data into a file called terraform.tf state that I'm gonna show you in a few minutes. So Terraform stores the IDs and properties of the resources it manages in this file, so that it can update or destroy those resources going forward. So the Terraform state file is the only way Terraform can track with track which resources it manages, and often contains sensitive information. So you must store your state file securely and restrict access to only trusted team members who need to manage your infrastructure. So in production, we recommend basically storing your state remotely with the Terraform Cloud or Terraform Enterprise. So now for this moment, we will inspect the current state of the infrastructure or EC2 instance using Terraform show. Yeah, it's taking a few seconds. Yeah, it's ready. So it has printed the response. So basically it consists of huge amount of data. Is close to JSON format. It's not exactly JSON format, but it's close to JSON. When Terraform created this EC2 instance, uh, it also gathered the resources metadata from the AWS provider and wrote the metadata to the state file. That's what the state file consists of. Um, so here, okay, here it is. Let me see. Yeah, so this is our Terraform show. When you give Terraform show, it has shown the state file, and this state file consists of the metadata of the EC2 instance with the way from which it gathered from the AWS provider. So AMI, we have given this AMI, and then ARN resource number. Here it is, it's US East 1, and then ID. So then after that, public IP address, availability zone, US East 1A, CPU core, and then this is what we're talking about. Instance initiated shutdown behavior is stopped. Instance state is running. So this is the present state of this infrastructure, this instance. And then instance type t2.micro. So before apply, after the validation, we have seen all these like unknown, like you'll get to know after that. So now you can see that key name TFKP that we have used, and private DNS and private IP, public IP. So we got 54 and then 172 as the first octet. Then here is our security group, and with the following subnet. Then tags, we have given the tags, the following tags. Then capacity reservation specification enclave. So all the metadata you can see, all the metadata of that instance. And then you see the most important metadata, volume size is 8 GB. So 8 GBs, and then this is the volume ID. This is our volume ID. Okay, this is about the basically using looking into the metadata uh, of the infrastructure or EC2 instance. It's like looking, inspecting the current state of the EC2 instance. So now let's manually manage the state and see what's going to happen. Okay, so here let me clear the screen. So now Terraform has a built-in command called terraform state. So this is for advanced state management. Use the list subcommand to list of the resources in your project state. So I'll give Terraform state and then list. So let's enter and see the magic. So it is AW/instance. This is what the labels that we have given, if you remember. So I will take you through that. Here is, so resource is AWS instance and then intro. So these are the two labels that we have given. So that's how the Terraform state command list will help us to find out the information, managing state of the EC2 instance. Now to for the troubleshooting, if Terraform validate was successful and your apply is successful and your apply still fails, so in that case, for the troubleshooting, so if Terraform validation that we have done it, it was we got it success. If you don't get success, and uh, if you get success and after that if apply well Terraform apply, if that fails, then you may be encountering maybe some region issue. You might be not giving the right region, or you might not be giving the proper security group ID, or you might be uh, missing the instance information or subnet ID something, or maybe. So there, these things you have to either it could be of your region, region, or it could be of security group ID, whatever it may be. Those changes should be made, and then save it, and then rerun the Terraform apply. So now let's do the change infrastructure exercise. So in this, what we are going to do is we are going to update the AMI of our instance with the new AMI, and then we will apply it and we'll see how things work. So that's what the change infrastructure, it's like changes in our infrastructure without touching our virtual machine. So we can do that. Normally it is difficult to do that, so here we can do it. So let's do it and see. So for that I will get into the Sublime Text so editor. So where so if you see this file here in resources, AWS instances, and then these are the two labels, and here we have EAMI. So this is where I want to do changes. This is Amazon Linux I've taken last time. So this time I'm gonna change this with the, so let me get into Amazon. So this is the instance, and we have the Amazon instance, Amazon Linux, which is running inside this instance. So let me find a new AMI, or directly I can click on AMI here. Here is the AMI catalog. So I'll just take the Ubuntu, the free version of Ubuntu. So let me type this free tier Ubuntu 18. So nothing has come. Sorry, Ubuntu 20 is also fine. Let me take 20. Nothing. Okay. Sorry. Yeah, I'll click on community. So now, yeah, there are Ubuntu, some Ubuntus. I'll select this Ubuntu. This is the first time I'm seeing. AWS Marketplace. I don't want to come into the marketplace. Okay. So let me get back to the AMIs that we have. So Amazon Machine Images. So go to the instance, and then we'll take the free tier instance. The either you can directly check. So Ubuntu, I'll go for the Ubuntu at this moment. That would be easier. So here is the Ubuntu again. So let me browse for more AMIs, and here you should find there are a lot of Ubuntus. I think whichever is the freest version, I'll go for that. Free tier only. I'll check free tier only. So all products got, so we got the free tier ones. So 17 got filtered, and then Ubuntu 22, no, Ubuntu 20. I'll go for this Ubuntu 20. So this is F6. Yeah. So I'll copy this, and then I'll paste this with the existing one. So I'll select it and paste it. So before it was 91 AMI. So this one is F6. This is Ubuntu. So now, so let's keep the remaining things same. So let's see. So we have done the changes. I'll save it. So now this update changes the AMI to Ubuntu AMI. So the AWS provider knows that it cannot change the AMI of an instance after it has been created. So Terraform will destroy the old instance and create a new one. That's how it works. So for that, what we'll do is we will go to that folder where our configuration file is there, and then open git bash there. So let me zoom it. Yeah, this is more than enough. So now it's time to apply the changes. So after changing the configuration, now it's time to run terraform apply. So so we'll click on enter, and we'll see what all changes is going to happen to our existing resources. So Terraform apply has been clicked, so has been entered. So now the things have been changing. So the first thing that had happened is AWS. Okay, before I click give a manual value, okay, or else first I'll execute it and then I will explain one by one. So I'll say plan, one to add, zero to change, one to destroy. This is what I want. So this is going to destroy the existing one, and then it's going to replace with the new one. So there are no changes. So do you want to perform these actions? Of course yes, I will say yes, because I only intended to do. So now the aws.intro, these are the labels for the AMI. So that the old one has been is being destroyed, and the new one is being added. So that's what is going at this moment presently. So let's see the what our changes are happening. So by the time what we can understand is, so there, here at this point you can see the plus symbol, and then negative symbol, and then tilde symbol. So we are going to understand each and every symbol, what does it mean, and also by the time the things are changing a lot. So we got an error. So creating EC2 instance invalid group not found. The security group SG07, it does not exist in VPC. So status code 400. So let me get into that, and I'll look into the VPC first, security, and then we'll solve that. Okay, so security group. Okay, we'll get back to the EC2 instance only, but then it's better. So we can get it directly also using. Okay, again it's stuck, again it's hung. So it takes some time, maybe while typing. Oh, okay, got it. So last time maybe I did not copy paste in spite of there is something wrong. So let me find out the security group name. Yes, we got it. Let me go to the security group, and then this is what the security group that I want. I'll just copy the security group ID. Here it is, security group ID, and then place it here. Where is that? Yeah, here, and then yeah, let me save it back, and then run it back. Terraform apply. So now let's see what's going to happen. So again it's asking for the same. So I'll type S, and that means the previous one already had been destroyed. Now it has to add. That's it, nothing much. So it's creating AWS instance. So let's see. Let's watch the process. Let's watch the procedure. Once it is done, then we'll go through the complete steps one by one. Okay, initial the destroying procedure, and then adding addition procedure. Everything we will go through step by step. So but the symbols you have to observe are the plus symbol. So the prefix minus or plus means that the Terraform will destroy and recreate the resource rather than updating it in place. So Terraform can update some attributes in place indicated. Yes, it's apply complete resources, one added, zero change, zero destroyed, all success. So let me go up and let's see step by step. So we'll look it here from this. where it is, it's too far. Yeah. I think, yep, here. So here if you see, uh, basically the if you use if you find a tilde symbol, so here you can see the will begin with this stage. The first one, the Terraform perform the following actions that it's been saying. So minus or plus basically says it will be destroyed and then it will be recreated in spite of in place update. So that's what the minus forward slash plus says. So this is basically it's going to destroy the old AMI and then replace with the new AMI. So that's called force replacement. And after that, you got a tilde symbol. Tilde symbol means updating in place. So it will just update without any destroying and all those things. For image, it has to destroy. For this, it's not required to do that. So then but changing the AMI for an EC2 instance requires recreating it. So Terraform handles these details for you. So and the execution plan displays with Terraform will do. So additionally, as you go up, you see plus, which are additions. You see tilde, that are in place updates. So you can see the lot of features has been added and few features. So here, if you see plus and minus, this is the Vault security group has been updated with the new. Sorry, this is the Vault security group has been destroyed, and then this one has been updated. So there are a lot of things which are added, which are removed, and some are in place updation also being done. So now as we come down, we come to the plan. So additionally, the execution plan shows that AMI change is what forces Terraform to replace the instance. So using this information, you can adjust your changes to avoid destructive updates if necessary. See here, want to add, want to destroy. First, you will destroy the old one, then you will add the new one. That's how the these things work. That's how the change infrastructure works. Then it will ask for your manual intervention. Then you have to give as if that is done. Then once again the Terraform prompts for approval of the execution plan before proceeding before proceeding. So you have to answer S to execute the planned steps one by one. So as indicated by the execution plan, Terraform first destroyed the existing instance and then created a new one in its place. So you can use now we can use Terraform show again to have Terraform print out and the new values associated with this instance. So here you can see the complete log with the new values associated, all the information, volume size, volume type, volume ID, everything. So that's how your infrastructure exercise uh, is done with it, and that's how your infrastructure, any changes that are related with infrastructure can be done. So we have now created and updated an EC2 instance on AWS with Terraform. So in this exercise, we will use Terraform to destroy this infrastructure. So once you no longer need infrastructure, you may want to destroy it to reduce your security exposure and costs. For example, you may remove a production environment from service or manage short-lived environments like build or testing systems. In addition to building and modifying infrastructure, Terraform can destroy or recreate the infrastructure it manages. So let's do that. Let's see how can we destroy it. Let's get back to the git bash again. So there is nothing much to do. So let me clear the screen here, and then the Terraform destroy destroy dsto destroy command terminates the resources managed by your Terraform project. So this command is the inverse of Terraform apply. So in that it terminates all the resources specified in your Terraform state. So it does not destroy resources running elsewhere that are not managed by the current Terraform project or the current Terraform project which is run by the current configuration file. So let's run it and execute it and see what's going to happen. So Terraform destroy has been executed, so it's running, it's a refreshing. So let's see. So it's asking me for a value. So we want to destroy the resources that we have created. So wherever you find the minus prefix indicates that instance, you see all are minus prefix. This minus prefix indicates that the instance will be destroyed. As with apply, Terraform shows its execution plan and it waits for our approval. You can see that it's waiting for our approval. In plan there is nothing, no addition, no change, only for destroying you have won. So we are ready to destroy here. So and it's asking for our permission. So once we give the permission, once we answer yes to execute this plan and destroy the infrastructure, so rest all will be history. Rest all will be history. So it's destroying. Let's see what's going to happen. So just like with apply, Terraform determines the order to destroy your resources. In this case, Terraform identifies a single instance with no other dependencies. So it's gonna destroy our instance. Let's see. So it's taking a lot of time. So I think is 10 seconds elapsed, 20 seconds elapsed. Is something wrong with our uh, what's that? Let me check. Let me save this. Is everything fine? This one is fine. Yes, I took more time, but that's fine. Destruction complete after 43 seconds. So destroy complete resources 1 destroyed. So in more complicated cases with multiple resources, Terraform will destroy them in a suitable order to respect dependencies. But where here we have only one instance, so it has destroyed as a normal case. So it's success. So let's get into the AWS console and see what is going to happen. So let me get into EC2 dashboard. So instances, how many are there? So first TF, so still let me refresh it and see it's gone. Gone means absolutely gone. There is no instance in North Virginia. So again I'll get into the instances. Yep, first TF state, it terminated. It got completely terminated. If you see here, it's destroyed, and here it got terminated. So that's how we destroy infrastructures. So this is the best example. So we have taken from EC2 instance, AWS, which is an EC2 instance that we have created in our earlier exercise. Then we have updated it. Then we have destroyed it. So let's look into one more example. So here we are going to build an instance or create an instances using a variable file. So the current configuration includes a number of hard-coded values. So Terraform variables allow you to write configuration that is flexible and easier to reuse. So let's add a variable to define the region, zone, and AMIs. So for that we have to create new file called variable.tf, so with blocks which defining a region, zone, AMS, and then after that we have to um, reference these variables in the main instance.tf, and then if you execute we should able to create it. So let's do it and let's see and let's do it. So before that I would like to you to also look into the prerequisites one more time, because I do not know like whether you are following our whether you're following it or not. If you're absolutely new here, so you just go back and watch the videos from the beginning and then so come to this exercise. But anyway, I just want to repeat it. So these are the prerequisites to do this exercise again. So you have to install the Terraform CLI 1.2.7, and then AWS CLI should be installed, and after that you have to set up your own AWS account, and then in that you have to create an IAM user with access keys, and finally you have to configure the AWS CLI with IAM user using access keys. So once all done, so then you can go for the exercise. So now let me open the directory one folder, and then inside that I'll create so new folder. So name of the folder would be variable tf instance, that's the name, and here I will open VS Code. So as usual, let me close the get started and then click on here. So let's write our first file. So before we write an instance.tf, it's better to start from the variables. So I will write the variables file first. So the name I'm gonna give is vars dot or variable dot or var dot, whatever it may be in short, because in short I will give it as vars variables dot tf. So you can see the symbol here. Yeah, I think it's clear now. So this part, it's a Terraform symbol. So as soon as you give the .tf extension, we got the Terraform. So we got it. The Terraform file is open. Now it's time to edit. So obviously this is a variable type, so it's a variable file, so all block types would be variables only. There is nothing, there is no debate in this. So we'll begin with a variable block type, variable variable block type, and then a region is the label that I want to use, and we open the block, and inside the block default region that we like to have is US East 1. So then this is our first argument, and then this is our variable, and this is our value of the variable. So then the first variable has been defined and allocated, and then we will look into the second variable block. Yeah, so variable block, and then I will use zone as zone 1 as a label, then open the block, and then inside that again I'm gonna write default, and default zone is US East, and I'll go with the 1A. So second variable also has been defined and assigned. So now I will write the fourth variable block, that is AMIs. Basically these fourth variable blocks are AMIs. So these are the block labels. This can be custom defined, whatever you want you can give it, it's not a big deal. So the first argument here would be type. We'll take it as map type, and then default this is our nested block inside that. So default, it has a nested block. So this consists of the AMS that I want to use. So first I want to go with the US East and then 1. This is the default region that I've selected. So let me go to the US East 1, that is Virginia. Yeah, it's North Virginia. So I'll click on the North Virginia. Yep, these are the security groups that are related to North Virginia. And then, however, okay, let me get into the EC2 instance directly. Then EC2 instance services, and then I want to get that AMI numbers. One I'll take US East 1, and second one I would take US West 1. Okay, this is North Virginia US East 1. So let me click on launch instance. Just give some sample Dan or Daniel. So here I will select again as usual. This time I'll check Amazon Linux, nothing different, just simple Amazon Linux. I'll check. Okay, I'll copy paste this in our code. So then the second I will take US West 1, and then the value I should get it. So let me get to the, I don't think North Virginia. US West 1 is North California. So I'll go for the North California, that is US West 1. So here I need to get AMI. So yes, it is SAM. Then browse for more AMIs, and this is the AMI of the same Amazon Linux, but the ID is different. So that's the reason we have taken that also. So with this we have defined the 3 blocks. Let me save this. So 3 variable blocks with the region, zone 1 and AMIs as a label. Okay, so let me save this one more time, and then I'll create one more file. So this is a providers .tf. So here we will add providers. Provider, for us we have only one anyway. Providers, okay, that's the wrong one. Providers .tfs, it's a Terraform file. So provider, here we'll have a provider block, and provider block label is AWS, and then inside the region, no, not capital, it's a variable I want to define. So region, and then what is our region? We'll take variable. So dot, what is our variable? Label of our variable of region, it is region is the label. So that's what you have to give it. That's how you reference. It's similar to Python. If anybody knows Python, it's very easy to relate with the Terraform. Okay, so capital RE region. Yeah, done. That's it. See, when I type tab, when I type R, you are the region, and then so your providers.tf is also done. That's also been executed. Sorry, that's also has been saved properly. So you have variables.tf and provider also done. Now it's time to create main instance file. For instance file, we will name it as Terraform where Terraform instance dot tf. This is the better one. Yeah, so where tf Terraform instance dot tf is the name, and then so now obviously here we have defined the variables and then providers. Now here we have to put the main resource block. So I'll type resource block resource, and then a label I want to go with is AWS instance, and then another would be so this is var instance, so I'll go with the var instance. Okay, so var instance, it's done. So then I'll open the block. So in this we are going to have a lot of arguments. The first argument would be AMI, as we know. AMI, the first argument is AMI. So AMI, from where we'll get it, you can only tell. We'll take var dot, and then let's get to the var. So in vars dot, AMI's variable label is capital AMIS. So let me get back to here. So capital AMIS, see, you got it? Clear? AMIS. And then from which region you want, again you have to take one more variable. Let me get to the region. So you have a region as a label. So then you have to select, you have to type, let me click on tab R, you got it, a region. So that's it, your AMI, and then their specific region has been allocated to the as a value to the AMI identifier or AMI variable. So then the second variable that we have is instance type. The second argument is instance type. Here instance type, as usual, will take T2 micro, that's a free tier 1. So T2 micro is done. So then we have availability zone, or else let's get to that. Okay, 3 files. I'll just open this and copy the things, or else I don't need to type again. We'll just edit it. Okay, so this is what AMI is done, instance type is done, and the remaining things I'm gonna copy it. Okay. That's okay, we'll edit it one by one. There is a missing indentation, that's fine, we'll do it. So availability zone, we'll check US East 1A, then we have to put key name. We'll make a key name, so because we have to create a key. Yeah, so let's create a key first. So we do not have a key name, let me create the key. Let me keep it this empty, and in I think where I am, so let me get back here. So I'm in North California, na? So I want it in US East 1A, so I will Oregon, North Virginia. Yeah, so here let me click here, and you'll find on the left side menu, you'll find key pairs, and then click on create key pair. Name of the key pair for this time is var tf key pair, and click on create new key pair, and go to the place where, and then cut it and paste it back in your directory where instance file is there. Yeah, this is our key pair. So now let me get back to this place, and what is that? The var tfkp. So var tfkp, so this is our key pair. So then we'll go for the security groups. Again, we have to get into the security group, and then we have to create a new security group. I do not know. So let's check the security groups. in the same region, North Virginia, US East 1, security groups are here. I will select, yep, this is the one. I'll check this one. The security group ID, I'll copy and then I'll paste it here. So done. So then after that, we have tags. We have tags. So I'll just cut it, paste it here. So in tags, let me open the block. This is a nested block. Inside that, we'll begin with a name, and then name consists of, what's the tag name you want to give. I'll give var instance, as usual. Project, I'll give Terraform. So this is done. Then one more and close it. Yeah, only two. Yep, done. This bracket closes with this one, and then this one is with this, so both are done. So let me save it. I think our files are absolutely ready. Now it's time to do step by step, starting with Terraform initialization. Then once the initialization is done, then we'll go for the format and validation and then plan, and then uh, one by one we'll go step by step. Okay, so let's begin with the Terraform initialization. For that, you have to open the git bash in a directory where all your instance files are there. So git bash, make it bigger. Yes, let me begin. So first let us check what all files are there. You see providers.tf, and then variable, this is instance.tf file, and then this is key pair, and this is vars.tf file. So let me initialize the Terraform directory, Terraform init. So it may take some time. So it's installing HashiCorp AWS providers. Of course, we have explored all those things in yesterday's session only. So I don't like to take you through all of these things. I will just do one by one as quick as possible, because we have to do two more exercises in this Terraform. So one is deployment of the application using Terraform. So other one is outputs. So that's how it works basically. So once it gets initializes, so as it happens with the git, it creates one directory. So there it's going to store the binary file of AWS provider, AWS Terraform provider, and similarly it creates, then after that, once that is done, so we can actually use Terraform. Once initialization is done, then we will check the format, whether everything is properly or not, and then after that we will go for the validation of the syntax and everything of our codes. Yes, it's done. So Terraform has been successfully initialized, and then most importantly, Terraform has created a log file, that's .terraform.log.hcl, to record the provider selections it made above. So include this file in your version control repository so that Terraform can guarantee to make the same selections by default when you run Terraform in it in the future. So that's what I'm just reading through faster so that we have done it in earlier session. So Terraform has been successfully initialized. That is the message of the first one. So now let's clear the screen and check the Terraform format, FMT. Yes, there are three files to be changed, 3 files to be modified, and they have been modified, I guess. So let's do it again, Terraform format, and see. So this time we did not get anything. That means they were thoroughly cross-checked and they were thoroughly verified. So now let's go for the Terraform validate. Success. The configuration is valid. It's pretty quick, but that's fine. So all steps are done. Now it's time to apply, and let's see what's gonna happen. Terraform apply. Yeah, it's gonna take more time because there are a lot of things to be done. So all are plus, maximum things are plus. I'll just go through it once. Okay, the network interfaces and a lot of things. So we have discussed about each and every block of this information known after apply, what is known after apply, and everything. So here the plan comes into the picture. So there is nothing to change, nothing to destroy, only thing, one infra to add. That's it. So do you want to perform these actions? Yes, of course. So I have to enter S. So I have entered it. Now action is taking place. Let's wait and watch what is gonna happen. So you kindly go through the process one more time. So what exactly is happening? So each step, you understand each step better, so that when you work on an actual scenario, real scenario, it would be much easier. So here in this case, you can see it's creating an instance, AWS instance dot var inst, and then I think 10, 20, 30 seconds elapsed. So I hope at least the 40 seconds. Yes, it's done within 37 seconds. It's pretty faster. Normally it takes 43 seconds, but this time it is created. The completion time is just 37 seconds. It's fantastic. So apply complete. Resources one added. Brilliant. And then 0 changed, 0 destroyed. So now let's get into the EC2 console and we will check whether it's been really created or just illusion or delusion. Let me go to the EC2 dashboard. One instance is running. I think we are done it. That's it. The instance name that I gave, var instance, because it's variable. Through variable we have done it, and then it's up and running in availability zone US East 1A, and then this is the public IP, and this is a security group that we have used, and this is the key pair that we have used. Brilliant, wonderful. I hope you are also able to do it. So if you are able to do it, congratulations, you have reached one step up, one level up. Okay, so now what we are going to do, a small activity, like it's we have done it already, but I want to do it one more time. So this time what I'm going to do is, it's like so I'll just take you through this one. Yeah, so define the input variable exercise. Through this we have done it. So if you see destroy infrastructure exercise, that also we have done it. Change infrastructure exercise. So this we have done it in with our previous way. Na? So now we have used a variable file, and then through the variable file we have built an infrastructure. So now what I want to do is, I want to do some changes in the file, some changes in our file, and then I want to see how it works. If I do changes, I want to change the key pair. So how can I do that? And I want to run the instance. How can I do that? Let's do it. So for that I will go back to our main instance file. So here I want to change this key pair. So for that, what I can do, I have to again get into the key pairs. So this time I want to put the world key, one more key pair. I want to create one more key pair. So where is that? It's elastic IP key pairs as well. So I will type it as key pair. It's var tfkp1. It's version 1. It's a new one. And then I'll create. So it's been created. Let me get into that folder and cut it and then paste it in your directory. So and the name, I'll just copy the name, yeah, and then I will paste it here, and let's see what's going to happen. Yeah, fantastic. Let me save the file, and again let me get into the git bash. So let me clear the screen first. So now ls lrt, you can see the var tfkp, that's a old one, var trf, okay, var rf kp1.pk. So let me check whether the name I have given correctly or not. Yes, correct. So name is correct. So now I just want to do some modification. I have done the modification. Now it's time to apply. So first let me check the format first. So Terraform fmt. So there is not much of changes to be done. Everything is fine. Then before we doing the validation and all those things, it's better to plan it first. If you do plan, so then we'll see what is going to change, then what is going to happen, so everything. So that's the reason I'll say Terraform plan. So then Terraform will plan how to do the changes based on the changes that I have given. So how can it does? So here you can see, so the tilde symbols, they are in place updates, plus these are new addition, and then minus will be a removal of the existing one. So they'll remove the existing one and then they will add wherever you find minus plus. So here you see CPU credits, okay, and here Dove SG security group, okay, that's fine. So in this case, to do the changes, if you want to replace with a new key pair, then obviously you have to destroy the existing one, and then you have to create the new one. That's what the Terraform plan is. That's how the Terraform has planned it. So you did not use the out option to save this plan. So Terraform can't guarantee to take exactly these actions if you run Terraform apply. So that's okay. So let me clear the screen and let's apply Terraform apply. I think I've saved the file. It should work. Yeah. It's asking the plan. Want to add, want to destroy. Let's see. I'll give S, and what's gonna happen? It's destroying the existing one, destroying the existing one. Here you can see the destroying the existing one, and then once destroyed, once it is existed one is destroyed, it's gonna create the new one. So let's wait and watch what is gonna happen, what's gonna happen in this case. So next, still destroying process is taking place. 30 seconds elapsed. This is too much. I think after 40 seconds it should be destroyed, and then next within 40 seconds it should come up with the new. Oh, 40, yeah, complete destruction complete after 43 seconds. Now it's gonna create. That's what the same thing. The plan. Want to destroy, it's been destroyed, then other one to be added, and now it's being added, but I think it takes 40 seconds this time. Okay, so 10 seconds, 20 seconds elapsed. Now okay, 10 more seconds I guess. Okay, so you just go through this 30 seconds, you just go through this complete procedure. So this is how you can actually, without touching your instance, you can do all the modification, you can create, you can change, you can destroy, everything you can do through Terraform. Oh, this time it's taking more time, it's 50 seconds. That's huge, that's huge. Yeah, it's done. Apply complete. Resources one added and one destroyed. Now let me get into the uh, now let me get into the EC2 console. So EC2 dashboard is here. So instance is running. Here it is. US East 1A var instance is running. Of course, 2 will run because in our file we have mentioned two. So one is at US East 1A, other one is also US East 1A with the uh, different instance IDs. So it's all done, it's all set. So you also keep doing it. So we have created the instances using input variables, and then so now we are going to do some inspection of the state of the file, and also we are gonna look into the various aspects which are mentioned in that state file, and then we'll do some manual management of the state, and then we will destroy the instances using the destroy command. Okay, let's get into the action first. So we will begin inspection of the state. Okay, so let me get back to the git bash and let me clear the screen first. So when you applied your configuration, Terraform wrote data into a file called terraform.lslolsa. So here you can see terraform.tf state. So this is the file. Let me click on cat terraform.tf state. See, this is what I'm talking about. Whenever you apply your configuration, Terraform writes data into a file called terraform.tf state. So this Terraform stores the IDs, everything IDs, and appropriate of the and IDs, and then appropriate properties of the resources it manages in this file. So so that it can update or destroy these resources going forward. So that's why it's called a state file, because through this you can actually alter the state of the your infrastructure. That is the reason we call it as a state file. Basically, if you want to, so the Terraform state file is the only way Terraform can track which resource it manages, and often contains sensitive information. So you must store your state file securely, and restrict access to only trusted team members who need to manage your infrastructure in production. So let's let's do some let's use Terraform show to instead of looking into this file directly, let's use Terraform show command to look into this state of the to inspect the state of the our infrastructure. So Terraform and then show. So it's gonna show the same file with a different, yeah, you can see. So we don't need to look into everything. So we'll see, for example, volume ID, volume size, and volume type. So now let me clear the screen. We have seen that most of the things we have covered in this. It consists of a lot of information regarding the state of the infrastructure, and we have seen in our previous slides. That's why I'm not going in depth. So you can also. So when Terraform created this EC2 instance, it also gathered the resources of metadata from the AWS provider and wrote the metadata to the state file. So now what we're going to do is we will manually manage the state. So let me clear the screen first. So Terraform has a built-in command called Terraform state. Terraform state. So when you add list subcommand to the list of the resources in your project state, it will give you that. Okay, for of list. So this is what the list we have. AWS instance is the one which you are using, and where inst. So this is about manually managing the states. Now it's time to destroy the instances, because we have seen enough, we have created. Now instead of manually going to the EC2 console and then terminating those instances, we will do it directly from the Terraform, because with Terraform you can create, you can change, you can destroy, you can do whatever you want to the instances. So that's what we are going to do here at this moment. Okay, so for to the Terraform destroy Terraform destroy command terminates the resources managed by your Terraform project. So this command is the inverse of Terraform apply in that it terminates all the resources specified in your Terraform state. So whatever resources that were mentioned in our Terraform state that we have checked before using that's what we called it as inspection, state inspection. So all will be terminated. So it's asking for the approval. So let me say yes to execute this plan and destroy the infrastructure. Destroy the infrastructure. So now it started destroying the existing infrastructure. Let's see how much time it's gonna take, the time lapse. Okay, so it's still destroying. 10 seconds elapsed and 20 seconds elapsed, and it should be destroyed within 30 seconds, or else it will go for the 40 seconds. Let's see what's going to happen. 30 seconds is also crossed. That means 43 or 44 only, so nothing much. So it, oh, 40 seconds crossed. Yes, it's done 43 seconds. I'm apt. I'm accurate. Fantastic. I've been using this Terraform for years and years. I know how it works. Okay. Destroy complete resources. One destroyed. So now let's get into EC2 instance and see what's going to happen. Still they're running. Okay. Let's refresh the screen and then see. Gone. Gone. Boom. Gone. So let me get into the instances. So these two instances were created before using the uh, using our files. Now those things has been terminated completely. So that's what terminated. Where one and so where instance and where instance, two instances were created because that's how we have written with the two different AMIs, and all things got completely destroyed with the one command and sub command. So that's how a Terraform is help help us, and that's powerful is our Terraform. Now let us look into the last exercise of Terraform. That's we will run a nginx server in our local host using a Docker containerization technique and then Terraform. So for to do this exercise, let's write what all things are required for us. So yeah, so exercise, run a Docker container nginx service in localhost local machine. So for that, the prerequisites, the Terraform should be installed. Then after that, you need a Docker desktop as it is a Windows machine. And then once Docker desktop is ready, then we can do the rest. All other things will fall in place. So what most important thing is, for this Docker desktop, you need to have, for Docker desktop, you need to have WSL, that's Windows subsystem for Linux 2 version. So these are our requirements. Once it is done, then we will create a, we'll write a configuration file, and then we will format, validate, and then apply it, and we will host that nginx server, nginx service. So that's what the process we are going to do. So let's jump into my local host machine and we'll see what all things we have. So first let me open git bash directly here. So clear the screen, and then I'll give Terraform and then subcommand terraform help. So this means I have Terraform installed in my system. If you do not have, then you install it using Choco. Choco install Terraform the easiest way, or else you follow the manual procedure that I have explained in the first exercise of Hands On Terraform. So we have Terraform. So now let me check. So we have Terraform. Let me go to the sticky note. So mark the Terraform. Then what is required is Docker desktop. So let me click on open Docker desktop, and I have installed the Docker desktop earlier only. So if you want, you install the Docker desktop. It's just a manual procedure. It's not that difficult. It's a similar way of installing an application, normal application. The similar way it also goes. So it's not that difficult. You can install, or else we will be installing Docker desktop again in our Docker module, in Docker module of iDevOps course. So if you see this, so Docker desktop failed to start. So fails to start. Anyway, so we have a Docker. That's the first important thing. So we, okay. So for us, we have Docker desktop. So I will cross this one, but it's failed to start. Why? So Docker desktop requires, as I have mentioned in sticky note, so Docker desktop requires Windows subsystem for Linux. So that's the reason Docker desktop failed to start, and it is red. Engine failed to start. So now I have to install Windows subsystem for Linux, Windows subsystem WSL, and after that only, that subsystem for Linux WSL, and then only I can move on for further to execute this exercise. So let me type WSL. Yeah, this I have, but I need to have a WSL. This is by default it comes, and then I need to have a WSL too. So for that, what I will do is I will go to the Microsoft Store, and then in this I will type WSL. Go to the apps section, and then WSL2. So Windows subsystem for Linux, it's free. So let me select this one, and then click on, so Windows subsystem for Linux lets developers runs a GNU Linux environment, including the most command line tools, utilities, and applications directly on Windows, unmodified without the overhead of a traditional virtual machine on a dual boot setup. So it has to come get, so it's taking time. So let me get back to this, and then click on this one more time. Okay. What's the issue? It's taking more time. This product, yeah, rest all it's fine. So anyway, here, yeah, the get option is available. So once you click on the get option, it will ask for your permission. Do you want to allow this app to make changes to your device? As of course I would. So now it's started downloading the WSL, that's Windows subsystem for Linux. So once it gets downloaded, then it will be installed. It's 151 MB, it's huge MB. So installing WSL through the store will allow you to get the latest WSL updates and features faster, so and without needing to modify your Windows version. To learn more about this version, you go to this page, you visit this page, and then you see. Okay, so basically 152.1 MB is the total, and 32.61 megabytes is the one has been downloaded thus far. So it's going to take more time. So by the time we will get into the, yeah, by the time it gets downloaded, what will we do? We will uh, get into this folder and we will create a third exercise. So here, so I'll create one more exercise. This I'll name it as nginx service terraform. So I'll just open it. So let me check the, yeah, it's 88.61 MB. Okay, so by the time we'll write it, this is the place where I need to write the so Terraform, basically using Docker container. So the name of the file I will give nginx service docker tf. That's the correct one. So now I will create a file. So let me open it in VS Code. Show more. Open with VS Code. Yeah. Let me close the get started and get back to the Microsoft Store and see the status. 136 MB. Okay. By the time, let me click on this. Now the file name I'm gonna give is nginx service container instance container nginx service container dot tf. Yes, that's the name we have given, and let's check the status. So it's completed. So downloading is completed. So now it takes some time for installation. So let it buffer for more time. So by the time, what will we do is we will type the code. So we will write the Terraform file. So let's begin with the Terraform block itself. So Terraform block, and then the first argument in that is a required providers. Again, we'll have a sub block, a nested block. In this, I want to use a Docker. Then again, we'll have a nested block. So in this, I have to mention our first argument. The source is so KRE cruise worker or / Docker, and then version greater than or equals to 2.13.0. Sorry. Yeah, it's done. Let me open Windows subsystem for Linux. So it's ready. Okay. Let me open it one more time. So now I'll close this and then I'll type WSL. Yeah, we got the new one, the latest one. It's in. So now let me type Docker desktop and open it. And still Docker desktop failed to start. Okay. So now let me go to the documentation and find the exact WSL2 that we can download. So it is Terraform documentation, Hashik Corp developer. So here we'll go with the Terraform. What's Terraform? Yeah, not this one. Use cases AWS. Okay, installed with AWS, and here we have install Terraform. Then in this, let me go and find the place where we can find. So Docker desktop, where is that Docker desktop installation? I just want to find out. This is Terraform installation, then Terraform, quick start, Docker for desktop, and Docker for Windows. So WSLT2 location. So let me get into that place. So install Linux on Windows with WSL. So this is, when you copy this, so Windows PowerShell run as administrator. This is not the way. Windows PowerShell, yeah. So now paste it. Windows subsystem for Linux is already installed, so that means our Docker desktop should start. Where should I? So now what's the issue? Apply and restart. Yes. Or maybe I have to restart the complete system itself. Okay, there is a lot of setup is done. Now let me reopen the Docker desktop engine. Docker. So turn on Docker desktop WSL2. Choose WSL2 based in checkbox apply. From this Docker menu, settings general, use WSL2 engine. Yeah, it's that only. Expose daemon on TCP. Okay, where? So let me. By default, it was checked. So now from red to orange, it's been changed. So now it's time. So RAM 0.667 GB. So it's become engine is starting. So let's so once it gets started, so let's work on. So RAM 1.5 GB, 1.50 GB it's taking. Okay, so reset to the factory defaults only. I don't want anything else. Reset the Docker desktop your factory defaults. As it's reset it. So now the status engine is stopped again because it's being resetted. So once it is done, let's begin. So actually I uninstalled the WSL just to explain this thing. So now while installing we face some issues, and we solved it. Okay, so it may take a few more seconds to solve it. So by the time we will get back to our uh, VS code and we will write the code. We'll write the Terraform configuration file. So our Docker block is done. Then our first Terraform block is done. So now let's write provider. Who is the provider here? Before the provider was AWS, but here in this case for us the provider is Docker, so that's what the label I'm gonna put. So Docker, and then inside that Docker host, I have to give the host, so that is npipe forward slash 4 dot forward slash 2 pipe, and then Docker engine. Docker engine, that's our provider. Then this is also done, so now let's move on to a file and the next a block, that is a resource block, and Docker container. A Docker container is the first label, then nginx is the second label, and then open the block, and inside that image, so Docker image and nginx latest, that's what we're gonna check, nginx dot latest version. So then name of the project, it's for learning purpose. Then ports, you want to expose that, again sub block, so internal port which is 80, for if it is external port that is 8000. Then I will, so I think block has been closed, that's it, enough changes are done. So now let's get back into the Docker desktop, but still it's taking time to start up. Okay, so apply and restart. By the time at least I will sign up. Yeah, that's correct, and then password is also correct, I hope. Yes, it's processing, so verifying the credentials, and so it's been logged in. It's connected with the GitHub, sorry, Docker Hub. So now I have to restart the system. So let me close this and then reopen the Docker desktop. So Docker desktop stopped. It has to start. So settings. Okay, still it's taking time to start it. So WSL. So after so long, so the Docker is up and running. So that what are the problem that we have faced, that's because of WSL. So we have installed the WSL, but it took some time to get back it took some time to start the engine, because see, it's like bike, when if you don't use a bike for almost 6 7 months, the engine will be cold and it's very difficult to start. Same thing happens. So here there is no oil, so there is no WSL, so obviously it's very difficult to start the engine as quick as possible. So Docker engine took some time to come up. So finally Docker engine has come up, you can see that, and I have logged into my Docker hub also. So I logged into my Docker hub, containers, images, volumes, everything you can see. So our Docker is up and running, our Docker desktop is up and running. So now let's get back to our work. So here is the file that we have written. So I will go through this file one more time. Of course we have discussed about the same when we were writing this file. However, I just want to explain, I would just want you to take you through this file one more time. So it begins with the Terraform block. So Terraform block consists of a required providers nested block. Inside that you have a Docker nested block. So this Docker nested block consists of a source and version. So version is very important. So here I put cruise worker / Docker. This is the provider I want to use. So note this down now. So I will show you after doing Terraform in it. So there the version I am going for is 2.13.0. So this version I'm going for, and then this is the Terraform provider for Docker I'm gonna use. That's cruise worker. Okay, so that's one block. Then we have second block, that's a provider, specifically Docker, and then host. Then the third block is about the Docker image. Here you can clearly see a resource, even the uh, block label itself is a Docker image, and after that nginx. So here we have mentioned the name of the image as nginx, and then with the latest tag. Okay, so then we have a Docker container. So you build the image, and after that you run the container. So label is Docker container, and then in nginx. So but from which image you want to run the container, so that's what the first argument is. In this image arguments we have mentioned the Docker image. You can see Docker image, it's a reference to the Docker image block is on, which is on top. So this has been a reference to here. So when you reference this dot as an attribute, nginx is the attribute, and latest is the another attribute to get the latest version. Okay, so then name, in spite of giving learning, I thought to give the better one, that is nginx server terraform, nginx server terraform container. So that would be the nginx service would be better, nginx service terraform container, and then ports, expose this container to 80 and external port 88,000. Okay, so that's it, it's all done. So let me minimize this. Of course you can see the complete piece of blocks in the Terraform configuration file. I will save this one. So now let's get back into the action. Let me clear the screen, and let us see ls. So lsa, so array, let me check. Yes, it's done. So now ls to see the hidden. So you have only nginx container.tf. So this is the only one you have, so nothing else. So now what will we do is we will clear the screen first, and then we will initialize the Terraform. So Terraform initialization, that's Terraform init. So initialization started. So now what it will do, it is finding the cruise worker Docker plugins. That's the version. The version that we are looking for is 2.1.3, 2.13.0. So I hope I will get it. So it's done. So Terraform has been successfully initialized. So you can see Terraform has created a log file, that's .terraform.log.html, and in addition to that it has also downloaded the plugin of Terraform provider Docker. So let's look into that. So let me clear the screen first, and then it's ls. So you got, after initialization, a .terraform folder, a .terraform directory, and .terraform.log.html, and then this is anyway configuration file that is existed. So now let me get into the .terraform file. Yep, ls, we a providers directory is there. Then let me get into the providers directory, then ls registry.terraform.io. So here in this directory we'll have all the Terraform providers, but for this purpose we have asked only one provider. What is that? The provider that we have requested is cruise worker. In that we want a Docker, and then version of that is 2.13.0, whatever way you pronounce, that's fine. So let me get into this also, and then ls cruise worker. You can see that cruise worker that we have mentioned here. Got it? So now let me enter into that also. ls. Now you find the docker. So that's what we have mentioned here, docker. So cd docker ls, it's 2.13.0. That's the version that we have mentioned, 2.13.0. So then we will enter into that also, and ls Windows AMD 64, then Windows ls. Here it is, here it is, Terraform provider docker version 2.13.0.exe. This is the binary file, this is the main file. When you run a git in, sorry, when you run a Terraform init, when you initialize the Terraform, this the plugin will be downloaded in this fashion. So, and other one, read.md, this is markdown file. Change log.md, this is also markdown file. If you want to see that, read mg, you can see that. That's not an issue, but it's not much of use. So let me get back to our work. Where are we now? Okay, we're back. We're exactly back on our working directory. So now let me clear the screen. So now we have, as we have initialized it, ls-a, as we have initialized the Terraform, now it's time to format it. So Terraform fmt, so one file should be formatted, the changes to be done, so that the minute changes that will be done by that. So Terraform fmt, so the changes have been done, so no file has been printed on the screen. So that means all set. Now it's time to do Terraform validate, and then we'll plan it. So Terraform validate, forget about the warning that has been deprecated. This dot latest, that attribute has been deprecated. That's fine. But finally, the success message we got, the success message got displayed on the screen. The configuration is absolutely valid, but there are some valid warnings as shown above. That's absolutely fine. That's absolutely fine. So now let's do the plan. Terraform plan, as usual. Warning has come, that's okay, neglect it because we are using the old version, but still fine. But the plan is to add two in as add two, and then 0 to change and 0 to destroy, 0 to destroy. So now let's get into the core of the Terraform. That's to apply all the changes that we want to the infrastructure, that using Terraform apply. So the action started. So we have gone through this Terraform apply response in our previous slides and then previous examples. So here I'm not going through it completely, so directly, but here the special things I want to mention is docker image.nginx will be created. So it's going to build the docker image first, and then after that docker container. So that thing, that's fine. So now it's asking 2 to add, 0 to change, 0 to destroy. So do you want to perform these actions? Of course I want to perform, so I would say yes. I will say yes. So I have said yes. Now it's time. It will create image first. So docker image nginx, it's creating the image. Whatever the way it will bring, that's okay, but it will create the nginx image with the latest tag. Once the image has been created, then it's going to go for, obviously, running a container. Let's see. So 20 seconds elapsed, still the image hasn't been created. I think what's going on here. So it's taking too much of time, I guess. Let's wait for few more seconds. 40 seconds elapsed and still docker image hasn't been. Is there any connection issue, login issue? Let me check my docker hub. Docker hub logged in, there is no issue. Still, what is the issue then? 1 minute gone, 0 seconds elapsed, 1 minute 10 seconds. So docker connection is fine, 10 seconds elapsed. Why it's taking too much of time? It's supposed to be done by now. So let me check. It's okay, this is proper. Login is also there. It crossed 1 minute 20 seconds. Oh, 30 seconds. What's going on? So I'm just okay. So network is also fine. Network is also okay. 1 minute 50 seconds. I do not know what's going on here. It's supposed to fetch the image by now. 2 minutes gone. Oh, I'm just waiting for. I do not know how much time it will take. It's keep on elapsing the time. What's the issue? At least it should have thrown the error. Okay, done. Fantastic. It took some time, but that's okay. So it took almost 2 minutes 21 seconds. That's huge, in fact. That's huge. Normally it should be 1 minute maximum or 30 seconds, 40 seconds, but it's huge. Okay, anyway, so our Docker image creation complete after 2 minutes 21 seconds, and this is the Docker engine, and then it's the nginx latest, and then id image id. So then it started working on the Docker container. It started running the Docker container. So Docker container creation complete after 1 second. That's fantastic. Then this is the idea of that. So apply complete, resources 2 added, and 0 changed, 0 destroyed. So now let us go to the directly to the browser and type localhost 8000 and click enter. Localhost 8000 and enter. That's it. Your application has been hosted using container in your local machine at port number 8000, because this is external. This is external. So whereas the internal one is hosting exposed to the internal inside the container, that's port number 80, and then port number 80 is mapped to the external port number 8000 of the local host machine. So this is how so successfully we have hosted the nginx default web page in your local machine using Docker and then Terraform with one piece of configuration file. That is the power of Terraform. So now let me go to the Docker and let's see whether it is possible to see that container or not. Here it is. You can see the container, I hope. It is nginx service tf container. This is the name we have given as nginx service tf container, and then its image name is nginx latest. Of course, that's what we given, image nginx latest, and then it's running, and port 8000 is mapped to port 80. Then it's 2 minutes ago it has been started, and then it's up and running. Now let me stop this the container from the Docker desktop and see what's going to happen here. So let me refresh the page. It's gone, all gone. It's gone, all gone. So now it's we will restart. That's all. So it proves that it's running from our Docker. It's a Docker container from our host machine at port number 80. So the port number 8000 of the container has been mapped to the port number 80 of the host machine. So that's the reason you're able to. Sorry. So other way around. So the port number 80 of the host machine. This is what the port number 80 of the 80. Port number 8000 of the host machine has been mapped with the port number 80 of the container. So that's the reason you're able to access here. But we are unable to access here because we stopped the container. So let's start the container again. Yeah, now it's container. It started just 0 seconds again, 4 seconds ago. So now let's go to the browser and check whether it is working or not. Refreshed it again. Welcome to nginx. It's all set, all up and running. Your container is up and running, and your application is up and running. You are able to see the web application, default web page of your application on your screen. Now it's time to destroy the application. It's time to destroy the resource that we have created using that. So for that, if you want to stop this application running on localhost 8000 port, the only option that we have here is, again, get back to your, the simplest and then fastest way is, we have a lot of options. You stop here and you can delete it manually. All those things we can do it, but the simplest way that we can do here is just come back to your git bash and clear the screen first, and then you give terraform and destroy. Yes, it's done. So it's basically minusing all the things whatever that it has added. So the plan of this is 0 to add, 0 to change, and 2 to destroy. So now it's asking, do you really want to destroy all the resources? Yes, of course we want to destroy. I'll say S a docker container dot nginx has been destroyed first, and then image also has been destroyed, nginx latest. So both the things has been destroyed. So now let's get back to the docker and let's see what's going to happen. Here it's gone, the page itself is gone, and let's get back to the browser and see what's going to happen. So I'm going to refresh it. So refreshed, and it's gone. No application, because there is no resource such, so that's why, that's the reason it's gone. So here there is no container, so container is also gone. So images, nothing. Volumes, nothing. Containers, nothing. Okay, all gone. So that's how with a one command you can create and you can destroy, you can update, and you can change the resources. So this is the benefit of Terraform. This is the, that's the reason I really like the Terraform. I hope after this course, after this complete sessions, you also started loving the Terraform. So if you love the Terraform, if you like my course, keep watching it, keep subscribing it, keep liking it, and keep spreading it, and enjoy the course, the next course that's coming forward. Enjoy the modules that are coming ahead. And then, as usual, all love from my side to you. Thank you, and see you again on another module of Intuitive DevOps for You course. Bye bye.